we discuss about concept of motion to little bit. Now we discuss what is the motion of Earth around Sun. Same way we discuss about rotational motion of Earth and we calculated the same. Now here in that part we discuss that motion is something that is depending upon observer, where observer stands. Like in case of geostationary or geosynchronized satellite, the person is standing on Earth and he is observing, that means imaging that satellite is there exactly on his head. So from observer, satellite is observed as stationary because it is not changing out its position. But if third person is observing from moon, then he may observe that both person, that is the person from Earth as well as satellite, is in continuous motion. Same way, everywhere you will find the same thing, that when we are traveling by train and a train is entering in station, usually people ask, if I am talking in Hindi, तो कौन सा station आया भाई? Keep in mind, station is not coming towards you. You are going in the station, but we are considering ourselves as steady and station is coming to you. So like that expressions are there. So motion is usually, we are considering here, the motion is considered as with respect to observer. The change in position, that is called as motion. Now here we discuss that Earth is moving around Sun and for that purpose energy is required, but we discuss that no energy is required because work done in that case is zero. As work done in that case is zero, energy requirement is not there. But we discuss that Earth is moving around Sun. Why Earth should revolve around Sun? And then there is concept of force. Now we are going in somewhat deeper part of this universe lecture, that what is the law about motion or what is force. First thing we have to consider, there are different forces. Force may be balanced or force may be imbalanced. I am taking an example, a car is standing on road, gear is neutral, and now at neutral position, suppose 4 people are pushing that car from back side, and same way 4 people are pushing that car from front side. Both are applying equal force, but directions are opposite. We will get that car will not move in any direction. It will remain as it is. The moment I am removing this 4 person, there is displacement in the car if sufficient force is applied by the people from back side. Now when both the forces are having equal magnitude but opposite in direction, at that time we are calling them as balance force. Whereas here I am removing this and only in one direction force is applied, then that is called as imbalance force. So first we should aware what is balance force and imbalance force. But again question is that what is force? Let us take out example. Suppose there is a car on road which is at neutral gear only. I want to move that car in the front direction of that car. I am not doing anything. Just I am wishing, okay, move that car, move that car. It will not move. Then somebody will push it from backside. Either externally or internal mechanism is there by internal mechanism. Then only that car is moved in moment. Means here something is required to apply on that car. Then only car will start moving. Now it will start moving means what? It is changing its velocity or changing its state of motion. Initially it was at rest position and now it started moving. That means its velocity changes. By applying our normal knowledge, we can say it is initially car was having velocity as u, say whatever unit, that is meter per second square. Same way, after some time it will attain speed. Suppose 1 meter per, sorry, not second square, it's second. So v, that is 1 meter per second. So its initial velocity, that is u, that is equal to 0 meter per second. Say why I am considering 0 meter, because 0 meter per second, because the car is in not motion. Now don't tell me that as car is there on surface of earth and earth is in rotational motion as well as revolutionary motion around sun, and that's why car is also not steady. Yes, we are aware of that, but still here in reference frame, what is the reference frame? Road, some of the buildings nearby or some of the hills, trees which is there nearby. From that reference frame, car is stationary. Now I want to render or change out the motion of car, and so we are pushing out from back direction, and after time t, say 5 seconds, 10 seconds, it will attain certain velocity. That will be, now here I am considering my final velocity, so that will be v, that is something, let us check, 1 meter per second. So this way we are changing out its velocity or changing out its state of motion. That is, initially it was at rest position and now it is in motion with respect to given reference frame. And that's why velocity change when something is applied, that whatever something is applied, that is called as force. Getting idea? So we are discussing certain fundamental part, in that we discuss what is force. Now here you are sure now what is meaning of force, that in order to change the state of motion or state of velocity, something is required, that something, that entity we are calling as motion, force. Now suppose car is having motion 1 meter per second, in that speed car is moving, and now I want to stop that car. Say simple thing is that if person is sitting inside that car, he will apply brake. As he is going to apply brake, that means what? He is applying opposite force. Frictional force is applied. Now frictional force is opposing in direction, and therefore that car stops moving. So something opposing force I had to apply, because car is now in motion. Now I am applying opposing force. Now here that opposing force is frictional force, or otherwise some whatever the 3 to 4 person, they were pushing out car from back side, they should come at front side and start applying opposing force. Then car will stop. That means when car is in motion and I have to stop that car, some opposing thing is required, that is also we are calling as force. That means force is not only required to get motion in the object, we can change out state of motion, then that is called as force. Now accordingly, if you are able to understand what is force, Newton is very clever person. He only able to define this all thing initially, and therefore we are saying this is Newton's first law of motion. What is Newton's first law of motion? Say, if any imbalanced force is not acting on body, then it will continue its state of motion. Simplified law. I am again explaining you. First thing, if any imbalanced force is not acting is important. So if any imbalanced force is not acting on body, then it will continue its state of motion. What is state of motion? Suppose that object is standing, then it will remain in standing position. That means velocity equal to 0. That is we are calling as rest position. So suppose object is at rest position, it will continue its rest position. Now like that, this is whiteboard. I am not applying any force on that. So it will continue as it is, the rest position. Suppose object is in motion, then the object will continue its motion. It will not change out that motion when any imbalanced force is not acting on body. Accordingly, I am sitting on a bicycle and just giving few pedals. The bicycle will be in motion, straight line motion, let us imagine. And after that, till I am not applying brake, bicycle should move in straight line direction only. Is it possible? Till infinite distance. Actually, it should be possible according to Newton's first law. But see, when I am driving out that vehicle, there are certain opposing forces I have to consider. Which are those opposing forces? Number one, we are there on Earth, and Earth is having thick jacket of gases. We are calling that as atmosphere. So these gases are opposing out. That means frictional force is generated. Can I remove this friction? Answer is I have to drive in vacuum, which is not possible for me. So I can minimize, and that's why if you observe racer cycles, for that racer bicycle, the person is not sitting in standing position. It is just bending out, that fellow, and sitting out. So minimize resistance of air or wind, the first part. Second, there is friction between road and tire of that bicycle. Can I minimize? Road must be smooth. But this friction I can't minimize. I can't make zero. I can minimize by reducing surface area of tire. That means the more thick tire, more friction. Less thickness of tire, less friction. That's why observe racer bicycle, you are having tire is very, very thin. As thin as possible. Second thing. But apart from that, there is mechanical friction. The wheel is rotating around that axle. There is friction between wheel and axle. So ball bearings are introduced. But not only ball bearings are sufficient, we have to add. Now what ball bearing does? Ball bearing is carrying out the sliding friction into rolling friction. Anyway, that we'll discuss later on. But we have to add here suitable lubricant so that frictional force will be still reduced. Then between paddle, that axle is there. There also I have to apply ball bearing as well as suitable lubricant, chain and all that. That means mechanically I should minimize this all friction. I am again using word minimizing and not making zero. Then my cycle can travel longer distance, and this way Newton's law is applicable. Now suppose we can able to minimize, reduce to zero the opposing forces. Then object will continue in moving. Like that Voyager 1 and Voyager 2. These spacecrafts are sent by NASA. Now these spacecrafts, they are traveling outside our solar system. They were boosted once only, and then they started out their journey forever till today. That means the recording date of this lecture, these Voyager 1 and Voyager 2, they are moving in the space. Now they are almost crossed out the boundary of solar system.